This is 1.3, and today we're going to be talking about equations with variables on both sides of the equation, okay? On both sides. So, this is very similar to 1.2. There's just one extra step that we have to consider, okay? So we're going to go through that today. So the goal here, so you can go ahead and write this goal down. The goal is when combining like terms, you want to collect variables on one side first. So if we have variables on both sides, we want to move one of them. And we're always going to try and pick the one that's the easiest to move, the one that won't leave me with nothing on one side, so I don't have to consider that at all. I'm going to always move the one that's going to leave me with something left behind on that side, right? Because eventually, once we get the variables on one side, we're going to try and get all the numbers on the other side, okay? So let's do some examples. That's the best way to do this. So, for example, example A, we have a negative 2x and a negative 7x on different sides of the equation. Notice that? So with this equal sign, it's like a barrier. That means I can't combine these two. I can't just put them together like I was doing before. What I need to do is I need to move one of them first. So we're not going to move the negative 7x. Do not do that. The reason why is because if I move this negative 7x over to this side, what's left over? Well, the answer is 0, but a lot of people mess that up. A lot of people don't realize that they would have 0 left over. A lot of people just get rid of the equal sign, and that messes up their whole problem. So we're always going to move the one that's going to leave something behind, right? So since we're leaving the 15 behind, we're going to move the negative 2x instead, okay? So that's going to be our first step, is to move that to the other side, okay? So we're going to move that to the other side, which cancels this out. So I'm left with 15, and then this becomes negative 5x. And now I just start going through the order. So we didn't have any distribution, but we did have like terms, which we already did. We combined the like terms right here, right? And then we just go through the order, and we see that the only step left is to divide by negative 5. In fact, some of you might be moving away from making this list right here. Some of you might not even need this list. So I would say you probably don't even need to write that down, okay? It's just a good reminder. Okay, so then when we're dividing, we get x equals negative 3, or negative 3 equals x. It really doesn't matter which order you put it in, okay? All right, let's do another example. Example B. So this time, what we're going to do before we move any variables around, because something you should notice is this 5x is inside the parentheses. That means I cannot move it to the other side just yet. First, I need to distribute. So let's go ahead and distribute, which gives us 15x plus 6 equals 15x, okay? Now I can move this variable. So I want to leave the 6 behind, so I'm going to subtract 15x. So we subtract 15x from both sides. But something weird happens when we do that. So if we subtract 15x, we're left with 6 on one side. But like I said before, when you subtract 15x from this side, you get 0. But 6 does not equal 0. So in that case, that means that there's nothing I can plug into x to make this true, because I'm always going to end up with 6 equals 0, no matter what number I plug in. So if that's the case, I'm always going to have an untrue statement, which means there really are no solutions to this problem. Okay, so if you get two numbers with no variables at the end, just numbers equal to each other that are not actually equal to each other, they're different numbers, you're going to put no solution. Okay? You can probably guess where this next one is going, but let's look at C. Okay, so C is going to be the other type of example. So first we're going to distribute, so let's go ahead and distribute that negative 2. So we end up getting this, negative 8y minus 2 equals negative 8y minus 2. Okay, and now we're going to move the variables like we wanted to before. So we're going to move, I'm kind of focused on moving this one to this side, but when I do that, notice I also get these canceling each other out. This cancels out and this cancel out. But what I'm left with is the same number equal to each other. Okay, wait, so that's always true. Before, we had a statement that was never true. You're never going to have 6 equal to 0. but negative 2 is always going to be equal to negative 2. So if that's the case, if you get the same number on both sides with no variables, the answer is infinite solutions, okay? All right, so I want you to go ahead and try page 22, 7 through 10 all. And go ahead and pause this video because I'm going to keep going. I'll give you a second to pause. And then when you come back, we'll continue. All right, let's continue. So we're going to go ahead and work through these problems. Try and figure them out. Okay. So first things first, I look for distribution. There's no distributive method here, so I'm just going to move my variables, right? So I'm going to choose to move the 3k because it's a smaller number and I like it more. But notice you'll get the same answer if you choose to move the 7k instead. So I'm going to move 3k by subtracting 3k from both sides. Okay, that's going to leave me with negative 1 equals 4k plus 2. Okay, and then the next thing I do is I just solve like normal now. Now that I only have one variable, I can just solve this thing. So subtract 2, which gives me negative 3 equals 4k. Divide by 4, divide by 4, and we get k is equal to negative 3/4. Nice. Okay, let's do the next one. Next one, we see that we have a distribution method that we have to do. We have some parentheses, so we need to move the negative 2 in first before we start solving the problem. So let's go ahead and do that. Negative 2x plus 10 equals negative 2x minus 10. Okay, this might look familiar, but I guarantee you're going to get an answer you're not expecting. Okay, so let's go ahead and get the variables on the same side. So I'm just going to choose to get rid of this one. I'm going to add 2x, add 2x. However, when I do that, these cancel each other and these cancel each other, leaving me with 10 equals negative 10, but that's not true. 10 is never equal to negative 10. Even though they look similar, they're not going to be equal to each other. So they're not equal, so I want to say no solutions, or no solution. And I'm just going to say SOL for short, okay? All right, let's do the next one. So for this one, like I said, I want to only move the one that's going to leave something behind. This, if I move this one, I'm not going to have anything on this side of the equal sign left behind. So I want to move this one instead. So I'm going to add 1/8 p to both sides, add 1/8 p, okay? And then these cancel each other, leaving me with negative 24 equals 3/8 plus 1/8 is 4/8 p. Before I continue, I can actually simplify this. In fact, I'm going to do that right now. This will be an easier problem if I do that. So it's going to give me negative 24 equals 1/2 p. Okay. Now when I have a fraction in front of a letter and I'm trying to get rid of it, or a variable that I'm trying to get rid of, I'm going to multiply by its reciprocal. So I'm going to multiply by 2 over 1, which means I got to do it to the other side as well. These cancel each other, leaving me with p on one side. 2 times negative 24 is negative 48 over 1, but I don't need to write the over 1 part. And my problem is done, okay? All right, let's do the next one. We're going to distribute the 5. But notice, I have another distribution method that I have to use, okay? Or distributive method that I have to do. So I have to do it twice. So let's do it with the first one. Let's go. We have 20w minus 100 equals 20w minus 100. Okay, you should start to see a pattern here. Same things on each side. So let's go ahead and solve this. Remember that there's a plus sign in front of these 20s here. Minus 20 from both sides. This gets canceled. This gets canceled. And so I'm just left with negative 100 equals negative 100. That's always true. So the answer is infinite solutions. Okay? And that's that one. All right. I'm going to do a shorter video to continue this because we have kind of a fun story problem to do next, which you might have noticed before. So let's go ahead and move on to the next video.